orbital filled always sigma bond. Okay, sigma, sigma, sigma. Okay. So filled sigma and filled pi orbital. This filled up orbital, carbon state and filled pi orbital. This filled pi orbital. It is filled. It is filled pi orbital here. Okay, it is filled pi orbital here. It is filled sigma orbital here. Filled sigma orbital here. Filled sigma orbital here. Sigma orbital here. Okay. Now here filled sigma orbital. Here pi orbital causes overlapping between vacant p orbital. Causes overlapping. Overlapping means delocalization of sigma electron this orbital, pi electron this orbital. Okay. So remember here, carbon is stabilized by interaction of the empty p orbital. So remember this is hyperconjugation. When sigma electron filled orbital causes overlapping empty orbital of p, this is hyperconjugation. But this is resonance. This phenomenon is pi orbital resonance. So now this causes resonance. Understood? It is resonance. It is causes hyperconjugation. It causes hyperconjugation. Okay. Everyone know hyperconjugation. Now remember vacant orbital. Delocalization of filled orbital. Overlapping with this orbital like this overlapping. Okay. So overlapping. This is known as hyperconjugation. This one is hyperconjugation. Hyperconjugation. This is known as hyperconjugation. Okay. But pi electrons. In this pi electrons, it is empty orbital. This pi electron. So delocalization of pi electrons. Okay. Resonance also participate and also hyperconjugation in both cases. Hyperconjugation, resonance, both are participate. Resonance. That's why here fourth option is correct. So this empty orbital is stabilized by filled orbital of sigma and filled orbital of pi bond. Pi bond shifted. That's why resonance here. Okay. Now sigma electron shifted here. Now here hyperconjugation. The both is stabilized to empty orbital, p orbital of this carbocation. That's why here fourth option is correct. Okay. Now any confusion? Are you getting this concept? So remember this fourth option is correct. Okay. Now question number 64. Okay. Now question number 64. Green paramagnetic species formed by heating caminophore 573 Kelvin. Everyone know potassium permanganate is purple violet color. Okay. Convert to green color. Convert to green color. To convert to chromatin. So remember here KMnO4 potassium permanganate heated at 573 Kelvin, 513 Kelvin. It convert to magnetons K2MnO4, K2MnO4 green color. It show green color. It show green color. Okay. And remember this. And that's why fourth option is correct. Okay. Everyone know fourth option is correct here. Now potassium permanganate, it convert to potassium magnet. Okay. This permanganate, it is magnet. That's why it is purple color convert to green color. Okay. So now it's purple color convert to green color. To green color. So remember this concept. Okay. Now next question number 64. Okay. 64, 65. Okay. So correct statement, beryllium is 3 valence orbital. Okay. So remember the correct statement. Okay. So beryllium has 3 valence orbital. Wrong statement. Beryllium, everyone know. Secondary group, beryllium, magnesium, calcium belong to secondary group. So what is orbital here? 1s2, 2s2, 2p orbital. Okay. So now beryllium has 3 valence orbital. How many valence orbital? In 1s subshell is 1 orbital and p subshell is 3 orbital. Total number of 4 orbital is present. How many orbital is present? 4. In p subshell 2px, 2py, 2p is a 3 or plus 1, 4 orbital. So here 4 orbital is present. It is 3. That's why wrong. First option is wrong here. First option is wrong here. Second option. Magnesium is maximum covalence is 4. Okay. So remember here in case of magnesium outermost configuration is 3s2. Now it is 3p6, it is 3d6. Okay. So now it is vacant. It is 1 orbital, it is 3 orbital here, and p is d 5 orbital. How many orbital here? 5 orbital. Now magnesium is maximum covalency of 4. So magnesium is how many orbital vacant here? He is 9 orbital. 5 plus 3 8 plus 1, 9. 9 orbital are present here. So magnesium, 9 orbital are present here. Okay. Now what is covalency? What is covalency? Covalency that means maximum number of bond formed by any atom. Okay. The magnesium does not form 4 bond. Okay. Maximum covalency is 4. So now wrong statement, covalency is 4. Wrong. Okay. Maximum covalency is 2 only. Okay. Now third. Some magnesium show coordination number 6 also. Remember coordination compound will be like this MH2O6 plus 2 oxidation number. The covalency means maximum number of bonds. Covalency may be expanded up to 6. Okay, possible is aluminum is 5 valence orbital. Okay. Wrong statement. Aluminum also shows 6 covalency. How many orbital aluminum also belong to third period? That's why 9 orbital. That's why wrong. Aluminum is also belong to third period. Third period, that means 3s orbital also vacant, 3p orbital also vacant, and 3d orbital also vacant. That's why 9 orbital. That's why it is wrong. Okay. Aluminum is 5 valence orbital. Boron is maximum covalency 4. So right statement is correct because boron show maximum covalency 4. What is covalency? Maximum number of bond formed by any atom. Okay. So now here boron tetrafluoride. Tetrahedral structure is tetrahedral, it can expand its covalency maximum up to 4. Now here boron. Okay. Now here fluorine, and one fluorine negative charge form coordinate bond with boron of vacant orbital. That's why it can maximum number of bond. What is covalency? Sorry. What is covalency? Maximum number of bond formed by an atom represents its covalency. Maximum number of bond. Okay. Maximum number of bonds formed by an atom. Maximum number of bonds formed by an atom. Any atom represents its covalency. Any atom represents its covalency. Represent to its covalency. So represent to covalency like ammonium ions. Okay. It can expand its covalency up to 4. Hydronium ions. Okay. What is covalency of oxygen? Up to 3. Oxygen covalency is 3 here. Nitrogen covalency is here 4 covalency. Okay. So remember this question. Okay. So maximum number of bond formed by an atom represents its covalency. That's why here boron can form 4 covalency. That's why correct. That's why answer is 4th correct. Okay. So remember this point. Okay. Now next question we discuss question number 66. Okay. Remember what is structure of protein? Primary structure, secondary structure, tertiary, quarter structure of protein. Okay. So now correct statement about peptide and proteins. Do you know proteins peptide linkage? Okay. What is protein? In protein, peptide linkage is present. Which linkage is present? Peptide. Okay. So remember this point, in peptide linkage is present. Which linkage is present? Peptide linkage. What is peptide linkage? Every amino acid is acid group and NH2 group, another amino acid NH2 group. Okay. It is one amino acid, like one amino acid, it is B amino acid. Okay. Now C double bond OH, it is hydrogen R group. It is R dash group. Now it is hydrogen, it is NH2. It is R group. Okay. R double dash R group. Suppose it is R group. Both are not equal. R is equal to not equal to R dash. Okay. So now elimination of water molecules here. So now how to form peptide linkage? Peptide linkage is actually amide linkage. Amide linkage is known as peptide linkage. What is here? Amide. Amide linkage. Okay. Amide linkage actually peptide linkage. Amide linkage is known as peptide linkage. Okay. So protein amide linkage is present. Okay. So only protein having the quaternary structure are biological active, not quaternary. All primary, secondary, tertiary structure are biological active, not only quaternary. First statement is wrong. Okay. Why? All are optical active, biological active. Only not quaternary structure of protein biological active. All structure of protein either primary, secondary, tertiary, quaternary. All are biological optical active. That's why first option is wrong here. Okay. Beta plated C structure peptide chain are held together by intermolecular hydrogen bonding. It's correct. Remember here, Beta plate structure here, beta plated structure here, C double bond is present here. Now, do you know acid is present here? One molecular acid is present here. Now here is NH2 group also present here. Okay. So now is formation of hydrogen bond. It can form hydrogen bond. Okay. Now again C double bond here is NH2 group is present here. So formation of hydrogen bond. So remember here beta seated structure. Okay. Beta plated structure. Okay. Beta plated structure, hydrogen bond is present. Correct statement. Alpha helical polypeptide chain twist into left-handed screw through intramolecular hydrogen bonding, not right-handed. Alpha helix structure is right-handed, not left-handed. That's why C option is also wrong. Tertiary structure of protein has, remember here, tertiary structure of protein. Remember here, tertiary structure of protein. Okay. Tertiary structure of protein has two or more polypeptide chain. Not only tertiary structure of protein has two or more polypeptide chain. Remember, tertiary structure only one polypeptide chain is present, two or more not. That's why wrong here. Remember. Tertiary structure of protein has two or more polypeptide chain, not only one polypeptide chain is present. That's why fourth option is also wrong. That's why which option is correct? Only second option is correct. Now question number 66, second option is correct. Okay. So question number 66, second option is correct here. So remember this, second structure is correct here. Okay. Now question number 67. Okay. Now here. Now it is also conceptual question. Now question number 67. What is given here? Now it is given 2a. What is given here? 2a. What is the equation is given here? 2a. Okay. Now 2a convert to k, convert to b here. Okay. Now it is reaction belong to zero order. What is reaction belong to zero order? Okay. It is given order of reaction is zero. Order of reaction zero order. Zero order reaction. Zero order reaction is specified here. Okay. Now it is given is specified here zero order reaction. Okay. Now K value is given here. If initial concentration of is 2 mole per liter, then time taken to 75% of the reaction will be complete. Okay. So now here T0 time. Right equation here. What is initial concentration? T0 means initial 2 mole per liter. 2 mole per liter concentration here 0. How to write equation after some time? 2 minus 2x. How much dissociated quantity? X here. So now 2x. CT concentration after some time. CT concentration 2 minus 2x here. What is coefficient here? X mole per liter is form concentration here. Okay. Now CT concentration. Okay. Everyone know derivation for zero order reaction. According to differential rate law, how to write equation? Minus 1 by 2 dA by dt is equal to R here. Understood? According to differential rate law. According to differential rate law. Do you know differential rate law? According to differential rate law, we can write rate of disappearance 1 by 2 dA by dt is equal to R. So now this disappearance multiply 1 by 2 rate of reaction. According to rate law. According to rate law, how to write rate of reaction? R is equal to K, A key power 0. That's why here R is equal to K. Now equation first and second, or equating equation first and second. We can write here R is equal to minus 1 by 2 dA by dt is equal to K here. Okay. Now 1 by 2 multiply here, so we can write here dA is equal to minus 2 K into dt here. Okay. Integrate here. T0 times T time. Okay. T time. Integrate here. C0 concentration. CT concentration. What is here? Integration. So we can write here CT minus C0 is equal to 2 into KT here. Understood everyone? Now put here value. So CT is equal to C0 minus 2 KT. So remember for zero order, what is relation? After some time later concentration, initial concentration 2 KT here. Okay. What is CT here? 2 minus 2x here. So put here. So now here given 75% completion. What is given? The time taken for 75% of the reaction will be. Okay. So now here 75% completion. That means here so put here 75%, x will be 75%, 0.75. Okay. 75% completion is 75. Okay. So put here value 2 minus 2 into 0.75 here. Okay. So what is here? 2 minus 1.5. So what is CT concentration? 0.5. Now x value put here, 0.75 multiply by 2, but this value is 1.5. So 2 minus 2x 1.5, so CT concentration will be 2 minus 1.5. What is in this concentration 2? What is K? K value is given 1. What is K value is given 1. So now put here 1 value. Now we have to find out T value, okay. So now it is 0.5. 0 to 2 minus 2t, okay. So what is 2t value? So now 2t becomes 2 minus 0.5. So 2t becomes 1.5, x becomes 0.75, okay. Understood everyone? Now t, what is time requirement? 75 minutes. So 0.75 minutes it will be dissociate 75%. Very easy question. Remember this coefficient is 2. That's why according to differential rate law we can write 1 by 2 dA by dt is equal to r here. According to rate law. Do you know rate law? According to rate law, we can write here r is equal to a ki power 0. That's why r is equal to k here, okay. Now equating both equations, the 1 by 2 dA is equal to this. After integration we get this value. Now Ct is equal to 2 minus Ct minus 2x here. What is Ct? C naught minus 2x here, okay. So put here x value 75% dissociation. That's why here 0.75. 0.75 multiplied by 1.5. 2 minus 1.5, that's why 0.5 here. Here's to the after solving we get T time is 0.75 minutes. The answer will be first option is correct. What is option here? First option is correct here. Option first is correct here, okay. Very simple question, okay, not difficult question. Now next question number 68, okay. So remember here question number 68, what is given here? 68, generally 3D transition metal having high melting point. Everyone know D block element have high melting point, high boiling point. Why high melting point, boiling point? General 3D metal have high melting point, okay. Correct statement. Involvement of 3D electron addition to 4s electron in the intraionic metallic bonding. Correct. Assertion, reason both are correct and explanation also correct. Remember here. Now 3D element are half-filled d orbital is present, okay. That's why more half-filled electron, more interaction force attraction causes attraction between atoms, okay. Remember here in 3D 4 electron is present, 3D 5 electron is present, 3D 7 electron is present, 3D 7. So which causes more unpaired electron? 5 electron. More unpaired electron, more metallic bonding, more interaction force between metal bond, okay. That's why here metal interaction increases. That's why melting point increases. More unpaired electron, more number of unpaired electron, more number of unpaired electron increases. That's why here metal interaction force increases, okay. Here metal interaction force, metal interaction force, metal interaction force increases, okay. Metal force increases. That's why here it causes more melting point, okay. Metal more melting point. Remember, involvement of 3D in addition to 4s electron, almost same energy. Remember here in 3D subcellular 4s almost same energy. That's why both involvement in bond formation, okay. That's why it is more melting point. Almost same energy. That's why both involvement in bond formation, okay. That's why here more melting bond. Assertion, reason both are correct and explanation also correct. That's why answer 4th is correct. Answer 4th is correct here, okay. Next question is given here. Now here consider the following plot orbital function against distance from the nucleus. Remember we have graph 3 types, okay. Now first is graph given psi versus r here, okay. Second graph is given psi square versus r here, and third graph is given here radial probability density 4 pi r square into psi square, okay. 4 pi r square into dr versus r here, okay. Understood everyone? 4 pi r square into dr bus is here. Okay, so remember here psi value will be positive negative. Wave function may be positive negative. Wave function may be positive and negative. Okay, psi square never be negative. Wave function is always positive. Radial probability density wave function is also positive here. Okay, if graph for S subcell start from this. Graph for S subcell start from height some height. In graph for PDF subcell. PDF subcell start from origin point. Graph for PDF sub start from origin point. Okay. In radial probability density, either whatever subcell is present, either as PDF, graph start from this. Okay. So now graph is given psi versus r. Okay. So do you know radial node? Now x-axis, it is y-axis. It is x-axis. Okay. It is y-axis. It is x-axis. Okay. So remember, if intersect on x-axis. Now how many times intersect to x-axis? This is defined to radial node. Remember here radial node. What is radial node? What is a radial node is equal to n minus l minus 1 here. Okay, radial node. Okay, and maxima. Now we have to check 2 points. Now it is radial node and second is maxima. Second is maxima. We have to check 2 point maxima n minus l here. Okay, so remember. We requirement, suppose we have to find out graph psi square versus r for 3p 4s subcell. So what is here radial node? 4 minus 1 3. Now graph start from this 1 radial node. How much radial node? 4. Put here 4. Else value as subcell 0 value. That's why 4 minus 3 3 radial node. That's why here 1 intersect, 2 intersect, 3 intersect. Okay, height will be increases. Height will be increases. Height will be increases. Okay, so 1 2 3 in 1. Maxima, what is maxima here? 4 minus 0, the 4 maxima. Maxima number 1, maxima 1, 2, okay. 1 radial node, 2 radial node, 3 radial node, and maximum 4 radial node. Okay. 3 maximum, 4, so now 3 radial node, 1, 2, 3. Height will be increases, height will be increases, like this, okay. So check here. So now here, the figure is 2 radial node. We have to 2 radial node. Here is no radial node, 0. Here is 1 radial node, not possible. Here is 1 to intersect. What is intersect here? 1 into intersect here. What is radial node here? 1, only 1 radial node here. So now D option only 1 radial node. Here is only 1 touch here. Okay, here is 1, 2. 2 radial node here. What is here? 2 radial node. Okay, understood everyone? So now here is 2 radial node. What is here? 2 radial node here. Okay, so now 1 intersect. That's why C option is correct. Answer will be C. The answer will be C here. Remember this point. Radial node maxima. How much maxima? 2 radial node means maxima will be. So remember here 1 maxima, 2 maxima, and then 1, 2, 1, 2. 2 radial node here. Intersect on x-axis. How many times intersect? No intersect on x-axis. That's why 0 radial node here. Only 1 radial node here. What is here? Only 1 radial node here. What is here? 1 radial node is here. Okay. What is radial node? 1, 2 radial node here. What is here? 1 radial node only here. Okay. So remember here, only C option is correct. Which option is correct? Only C option is correct here. Okay. So remember this. If psi square versus r, graph start from S subcell, its value will be positive, wave function negative. Psi square never be negative value, only positive, positive. It is graph will be upcoming, forward direction. In radial probability density is 4 pi r square into dr versus r. Either S subcell P start graph start from origin point. Okay, and it is positive value, never to negative value, never to negative value, positive, positive value, never to negative. That's why here to check radial node and maxima. Okay. 4 radial node, suppose here 4, now it is 1 radial node, 2 radial, 1, 2, 3 radial node here, 4 is subset, 3 radial node. What is maxima here? 4, so 1 maxima, 2 maxima, 3 maxima, 4 maxima here, okay. So now graph start from this, now 3 radial node, not stop graph here, maxima and then not touch here, understood everyone? Graph will be like this, maxima and not touch here, maxima, don't stop, we required 1 radial node, 2 radial node, 3 radial node, you can't stop graph here, you can't stop graph here. You would proceed to maxima and then downward. Maxima is a requirement. Now graph we can't stop here. 1 radial node, 2 radial node, 3 radial node. We can't stop graph here. We can't stop graph here. Maxima and then downward. Okay. We required maxima. We have to follow maxima also. That's why here C option is correct. What is here? C option is correct. Okay. Next. Identify question number 7. Identify a reaction which give aniline as major product. Okay. Now here is given question number 70. What is given question number 70? Identify the reaction which give aniline as a major product. Okay, everyone know first option is given, question 70, cyanide. Everyone know lithium aluminum hydride, the strongest reducing is it? Lithium aluminum hydride is hydride donor. Okay, H negative donor. What is here? H negative. What is here? H negative donor. Okay, it give H negative hydride donor. Reduction. After reduction, it form CH2 NH2. What is form here? CH2 NH2. Aniline is formed here. Okay, reduction here. Okay, understood everyone? So remember here, it form aniline. Okay. So now cyanide convert to aniline. The major product aniline. The first option is correct. Okay. Now second. Everyone know aniline is major product. The first option is not aniline. It is CH2 aniline. It is amine, not aniline. It is amine functional group. 1 degree amine is not aniline. It is 1 degree amine, not aniline. Not aniline. That's why first is wrong. Okay. Second, B option. Okay. It is Hofmann bromide reaction. Everyone know Hofmann bromide reaction. C double bond NH2 is here. Everyone know Br2 plus very important reaction. KOH plus Br2 is given. Okay. So now one carbon less product, number of carbon minus one product side is formed. Okay, what is product here? One carbon will be removed and formation of aniline. So correct statement. B option is correct. Now sodium borohydride does not reduce this. Okay, remember this concept. Sodium borohydride does not reduce to NO2 group. Okay, sodium borohydride. No reaction with sodium borohydride. Moderate reducing agent does not reduce to nitro group into aniline. Okay, it reduced to only 3 group. Aldehyde convert to alcohol, ketone convert to alcohol, acyl chloride convert to alcohol. Only reduction of 3 group. Other group no effect. Okay, now C option. Fourth option. Now HCl plus water. Okay. So remember here D option is given aniline. Okay, aniline react with NH. C double bond CH3 is here. Okay, so now react with HCl plus water molecules here. HCl plus water molecules. Remember here, first break down it. H positive here and Cl negative attach here. Okay, HCl. Okay, so what is here? Aniline. For this product here, aniline is formed product aniline. What is here? CH3, C double bond of CH3. Okay, again water molecule attack on the formation of acid. So now final product is acid is formed. Okay, so now acid plus this product. Now remember here, choose the correct option from the option given below. So remember B and D. B and D both give aniline. It form B and D. The answer will be B and D. First option is correct. Question 70. Answer will be first. Okay. Remember everyone. Very simple. Okay. It is 2 degree amide reaction. Now shifting of this bond. Negative charge positive. That's why H positive attach. Cl negative attach. Shifting of this bond. That's why negative positive. H positive attack on this. Cl negative attack on this. There is formation of aniline plus acetic acyl chloride and water molecules again attack. So now Cl group better living group. That's why OH replaced by this the formation of acid here. Okay. So remember this concept. Okay. Now remember next question is given. Among the following given species, the spin magnetic moment is highest for. Okay. So remember spin magnetic moment calculate by question 71. Okay, everyone know. And the magnetic moment, what is formula of magnetic moment? Question 71 mu is equal to root n plus 1 Bohr magneton, n plus 1 Bohr magneton here. Okay, now put here value. Now unpaired electron, what is n here? Total number of unpaired electron here. Okay, unpaired electron here. Okay, now Fe Cn is strong field ligand. Okay, now calculated the oxidation number Fe. It is given Cn. It is given 6. It is given -3 charge. Okay, so what is your oxidation number? -6 is equal to -3. So what is X here? +3 oxidation number. The Fe plus N +3 oxidation number. Okay. So now 3d6 4s2 configuration. 3 electron remove. So how many electrons remove? 3 electron. Fe +3 oxidation number. That's why 3d6 4s2. 3 electron remove. That's why 3d5 4s0. 5 electron is present. Okay. So remember, always unpaired electron decided by strong field ligand. Okay, so now remember, listen perfectly. Okay, listen properly. Always unpaired electron defined by CFT, not VBT, not VBT. So remember here, coordination number 6 here. So now coordination number 6 here, EG orbital upside and T2G orbital downside. T2G orbital downside here. Always remember, CFT decided, unpaired electron who decided? CFT, not VBT. So how many electron here? 5. Strong field ligand, that's why 1 electron, then pairing causes. Okay, how much unpaired electron here? 1. The first option only 1 unpaired electron is present. How many unpaired electron? 1 is present. Always CFT decided to paramagnetic diamagnetic nature magnetic moment, not VBT, not VBT. Remember this concept. Train your CNS. Understood? So remember, train to your CNS, central nervous system. Always CFT decided to unpaired electron, not VBT. Remember this point perfectly. Okay? Remember. Now second option. What is unpaired electron here? 1. Now second option is given. Second option is given CO. What is given here? CO. Now CO NS3. It is given NS3. Now it is given 6. It is given plus 3 charge. What is given here? Plus 3 charge is given here. Okay. Now again, what is oxidation number? Plus 3. Now cobalt plus 3. So what is configuration? 3d7, 4s2 here. Okay. Now remove 3 electron. Now 3d6 electron here. Again EgT2G electron. Coordination number 6 here. It is a strong field ligand. Again causes pairing 1 2 1 2 1 2. How many electron here? 6. Unpaired electron is 0. The unpaired electron is 0 here. Okay. No unpaired electron is present here. Now third option. Now check in third option. Okay. Now check in third option. It is given Ti. What is given here? TiH2O. What is given? TiH2O plus 6 and plus 3 charge is present here. Okay. So scandium, titanium. What is concentration? 22 plus 3 oxidation number. So what is here? 3d2, 4s2. How much charge here? Plus 3 charges. Ti plus 3 charge is present. Now remove up 3 electrons. So now remove electron 2 from S subset. So now here 3d1. That's why here unpaired electron is here 1. How much unpaired electron here? 1. Now fourth option, check MnCn whole plus 3. Again, it is weak field ligand. Sorry, here weak field ligand. Okay. But after removal of 3 electron, only 1 electron is present. That's why here Eg or T2G doesn't matter. Only 1 electron is present. Okay. So now here 1 electron. That's why here 1 unpaired electron is present. No effect of strong field ligand. No effect of strong weak field ligand if D1, D2, D3, 3 electron is present. Okay. So remember this point. Okay. Now fourth question. Now it is given Mn. Cn6 minus 3 charge is given. So again Mn, now it is given Mn, Cn6 minus 3 charge is given here. Okay. Right, is electronic configuration. What is Mn oxidation number? Plus 3. Everyone know 6 plus 6 minus 3 plus 3 oxidation number here. What is oxidation number here? Plus 3 oxidation number here. Okay. So now write configuration, electronic configuration. 3d5 4s2. Remove 3 electron. So now 4 is 0 here. Now it is 3d 4 electron. How much electron here? 4 electron. So now 4 is 0 electron. 3d 4 electron is present here. Okay. So now filled electrons 4 electron is present here. Okay. So now half filled electron strong ligand. That's why causes pairing. The unpaired electron is 2. So remember here, first option is 1 unpaired electron. Second option is 0 unpaired electron, third option is 1, fourth option is 2. The maximum number of unpaired electron is fourth option. How many unpaired electron? 2. That's why answer will be 2. So remember answer will be 4. 4 is correct answer. Fourth option 2 unpaired electron. First option 1 unpaired electron is present. What is unpaired electron? 1. Okay, here 1 unpaired electron. Second option 0. Second option 0 here. Third option 1 and fourth option 2. That's why here 2 is correct. Okay. Maximum unpaired electron magnetic moment will be maximum. Remember this concept. Okay. Now question number 72. Okay. Everyone know geometrical isomers, facial, meridional, Ma3B3 type. Remember the complex facial, meridional. Okay. Remember here question number 72. Everyone know facial. Everyone know facial and meridional. Okay. Facial and meridional. Remember this Ma3B type. Everyone know this Ma3B3 type show facial meridional. Check here. MX6 does not show geometrical isomers. Ma4B2 does not show. Does not show. Third option, Ma3B3 type, monodentate. Both are monodentate ligand. A and B are monodentate ligand. Now we can draw here facial madronal. Okay, facial means, remember here, what is the facial? Facial means one plane, all are same ligand. Here is PY, PY, here is PY, here is PY, here is PY, here is PY. Same plane, all are same plane, same ligand is facial. Okay. Now it is chlorine, it is chlorine, it is chlorine, it is chlorine, all are same. This plane also same. Now facial, yeah, fake isomers. Okay, all are same, all are same. Now remember here, now it is axis. Okay, now remember here it is axis. Okay, now it is Cl, Cl, Cl. Remember here. Now along this plane, okay, now here is Cl, Cl, Cl. According to this plane, all are same. Now this plane same. Chlorine, chlorine, chlorine. Here is Py, pyridine, pyridine, pyridine. Both are same plane. That's why facial. Along one face same. That's why facial here. Now meridional, not same. Meridional means not same here. Like this. Suppose it is given chlorine. Now how much chlorine here? 3 chlorine. It is given Py. So 1 chlorine Py. Okay. So now here is Py. Here is Py. So not same. Understood? Because along this plane, it is chlorine, not same. Here is Cl. Here is, remember here, both are same group. Okay. Now it is Cl, it is Cl given. Oh, okay. Now two Cl is same here. Okay. On along axial axis, both are same group. Okay. Now here Py. Now here Cl. So now it is different. Py, Cl, different. That's why Pl not same. Py, Cl, different. That's why it is meridional, Mara isomers. So remember it is facial, it is meridional. Okay. So remember it is facial meridional. Only observed in Ma3B3 type coordination 6 molecules. Remember this. It is observed only in Ma3B3 type. Ma3B3 type molecules. Remember this concept. That's why answer only fourth option is correct. Now question 72. Answer will be fourth. Answer will be 4. Answer will be 4. Answer will be 4. Okay. Remember this. Now question number 73. Very simple question. 1/3 electrolyte in aqueous solution. The ionization at 1 ions, it is 2 ions. Now for 73, after dissociation, ionization, it gives coordination compound, one option. Okay. Cl NH3 and it will be Cl2. It will be 2Cl negative, 2Cl positive, 2Cl negative here. Okay. Now how much ions here? 1 ions plus 2 ions. The ratio will be 1/2. Remember here trick. What is here? Cl2. That's why here 2Cl negative ions. 2Cl negative ions. Whatever charge on outer powder sphere. What is here? 2 negative. That's why here 2 positive. Charge will be always equal. Okay. So 1/2 ratio. Coordinate sphere always produces 1 ions. What is trick here? Coordination compound always produces 1 ions here. If it is 2 ions, that's why 1/2 ratio here. Okay. Now second option. What is this? The second option is given here.